All right, here we go, molarity. Here we go. We're almost done. Okay, we talked about, or we will talk about, depending on period, molarity. Formula is how many moles of solute, and we talked about solute in a solution is the substance that gets dissolved or surrounded by water molecules, or the solvent. So it's the ratio, it's like concentration, the ratio of moles of solute per liters volume of a solution. S-O-L-N, solution. Okay, so let's take a look at the first problem. These are really easy. It's a simple division problem. But if you don't know how to do a mole calculation, see the unit moles, you might be in trouble here. So hopefully you know how to do a mole calculation, and hopefully you know your compound names. And if you don't, there's extra practice on the website that you have the option to do. Let's take a look at number one. Find the molarity of 2.8 moles of lithium chloride. 2.8 moles of lithium chloride. Lithium has a charge of positive 1. Chlorine has a charge of negative 1. EOA, equally opposite, stick them together. LiCl. In 0.85 liters of water. So, lithium chloride, metal, non-metal, right, will be pulled apart in water. Positively charged ions, negatively charged ions in solution of water. So what is the solvent? This is the solute, okay? So this negatively charged ion will be surrounded by the positively charged ends of the water molecule. This will be surrounded by the negatively charged ends of the water molecule. Okay, a little review right there. So let's do the problem. Here we go. So you're given 2.8 moles. You're given moles already. So right away you can go right to that. Simple. 2.8 moles of LiCl divided by 0.85 liters of water. Okay, this is molarity. Say 2.8 divided by 0.85, the molarity, when you divide it, is 3.3 molar of lithium chloride in water. There's your final answer. 3.3 molar in lithium chloride in water. Now, how do we change molarity? What if I increased this amount and added more lithium chloride in the same amount of solution? The molarity would go up. You would strengthen the solution. If you're adding more solute, right, in the same amount of solution, it's going to strengthen. Okay? What if I wanted to dilute the solution? Here's the situation. Once you've already added the stuff, it's dissolved. How can you dilute it or weaken it? You can't pull out the dissolved solute. Okay? How do you do it? You add more solution. You add more water, add more solvent. Is that clear? So this value goes up. So to dilute the solution, you add more solvent. To strengthen or increase the molarity of the solution, keep the same amount of solvent, add more solute. But here's the thing though. You don't want to, if you keep adding it, right, eventually you'll get to the point where the solution is saturated. Okay? And we'll talk about that if we haven't already next week. But again, to dilute it, add more solvent. To strengthen it, add more solute. So simple equation, simple problem right there. Okay? Here we go. Number 2. Again, simple. Find the molarity of 2.5 moles of sodium bicarbonate and 2.9 liters of water. So again, molarity equals moles of solute over liters of solution. Okay, so we got moles of solute. I've got 2.5 moles of sodium bicarbonate, NaHCO3. Again, equal opposite alert. Positively charged sodium, negatively charged bicarbonate. Okay? Again, it's ionic. They break apart. Okay? And can be surrounded in solution. So overall, you've got, and it's in water, so you've got 2.5 moles of sodium bicarbonate divided by 2.9 liters of water. When you do the math, it comes out to 0.86 molar. 0.86 molar of sodium bicarbonate in water solution. Okay, and there's your final answer. 0.86 molar solution. Now again, how do you strengthen it? Increase the solute. How do you dilute it? Increase the solvent. Okay? Strengthen it, increase the solute, dilute it, increase the solvent. So if I dilute it, if I increase the solvent, the molarity goes down, the concentration goes down. If I add more solute, that ratio changes. This goes up. So the greater the molarity, the stronger the concentration. The smaller the molarity, the weaker the concentration. Okay? Now that's an easy one-step one. Now how do you know if it's two steps or one step? Let's take a look. So the first two I set up there on purpose as moles. Now I'm going to give you grams. Oh boy. So now you got to find 25.2 grams of hydrobromic acid. Oh boy. Or hydrogen bromide, as some of you said. Hydrobromic acid, HBr. Hydrobromic acid in 3 liters of water. Okay. You're given grams, but I need moles. Oh no. So look up top, I put up for you atoms, molecules, compounds, moles to mass. So you start off, you write down 25.2 grams of HBr. Mole calculation, mole calculation. I put this unit down here. Every number has a unit. Every number has a unit. Arrange them so they cancel. Cancel, cancel. What goes here though? The molar mass. You find the molar mass. The molar mass. 80.9 grams. Okay? My numbers are correct. Bromine is 79.9. Hydrogen is 1. Again, when you do this in high school, they'll do significant figures with you. This will vary slightly. Okay? But at this point, we're getting you comfortable with the setup. Okay? So you're familiar. Up here, it's 1 mole. HBr. So then you take 25.2 grams divided by 80.9 grams, you get 0.31 moles of HBr. Wasn't that great? 0.31 moles of HBr. Now we can find molarity. Now we can find molarity. We have moles. Okay, so you have to do this extra step to get to there. So I did this, I'm going to erase this part, and now we're going to find molarity. And again, here's our formula, moles of solute per liters of solution. So you take 0.31 moles HBr divided by 3 liters of solution. 3 liters of H2O. So you take 0.31 divided by 3 liters. And the answer is, I've written down. The molarity is going to be 0.1 molar of HBr in water. 0.1 molar. Okay? Now, again, how do we strengthen a solution? Add more solute, add more stuff to get dissolved and surrounded by water molecules. How do I weaken it? Add more water. Okay? Questions on that? Write them down. Okay? So again, to dilute it, you add more solvent. To strengthen it, add more solute, get more stuff dissolved. Again, there comes a point though where you can't dissolve anymore. Then you're at saturation, you're at a saturated solution. And we'll talk about that in class more so, or we'll start to, okay, depending on what class you're in, okay? So again, there's your next example. And we'll do one more 2-step problem, okay? So it's either 1 or 2 step. Last problem, number 4. Find the molarity of 46.5 grams of sodium hydroxide. Oh no, it's hydroxide. In 6.5 liters of water. Okay. NaOH, equal opposite alert. Okay? So, we have to get moles of sodium hydroxide. You need to get moles of sodium hydroxide. So you write down 46.5 grams of NaOH. Okay? Convert to moles. Multiply it. Here we go. What unit goes down there? Mass in grams. Over 1 mole. 1 mole. What's the molar mass of sodium hydroxide? Again, sodium is going to be 22. We'll make it 23.0. In high school, they'll make you do more. They'll go with significant figures. Again, that'll be in high school. And if you're my high school people watching, I don't do significant figures in 8th grade. Okay? I'm more worried about the setup and the concept. Okay? Again, this is going to help you, sometimes you want to watch it at a basic level before you go crazy over there. So hopefully this helps. So I've got for sodium, right, 1 Na, 1 times 23. For oxygen, 16.0. And for hydrogen, I got 1 hydrogen. 23, 16, and 1 gives me 40 grams of sodium hydroxide. The molar mass, there it is. Okay, so to get moles, I take 46.5 divided by 40. I'm looking at 1.16 moles of NaOH. Okay, so I have that. Now I can find molarity. Okay, now I can find molarity. So, again, we know molarity equals moles of solute divided by liters of solution. Okay? So we take 1.16 moles of NaOH, that's your solute, divided by liters of solution. We've got 6.5 liters of solution. Okay? So, 1.16 divided by 6.5 gives me a molar mass, or excuse me, a molarity of, let me double check that. 1.16 divided by 6.5. 0.17 or 0.18 gives me 0.18 molar of NaOH in water. And you're going to learn that this is sodium hydroxide, that is a base. Okay? So how do we strengthen it? We increase the quantity, okay, of solute and maintain this. This will strengthen it. Or if we want to dilute it, we increase this value here. Now, let's take a look at this real quick. So there's your answer for number 4. You can do the rest of the problems on your own. Real quick, take a look up here. Let's use easy numbers. Let's say I've got 10 liters of solution in 1 mole of a substance of whatever, whatever you want to call it. What's the molarity going to be? What's the concentration? 0.1 molar. Okay. Now let's strengthen it. Let's make 2 moles. And that would mean whatever grams. So if it was water, if 1 mole of water is 16.0 grams of H2O, right? Because that's the molar, 18. 16 for oxygen, 2 for hydrogen is 1 mole. What if I do 36 grams, shouldn't use water. Here, let me do something else. Because it's water and water. What sense is that going to make? Let's go NaCl. Let's go NaCl, each NaCl 23 and 30. Hold on. 58. Okay, so for NaCl, let's say we got salt solution. Okay, so for NaCl, we've got the molar mass for NaCl is approximately 58 grams. NaCl is 1 mole. So 2 moles of sodium chloride would be 58 times 2. You're looking at 116 grams of NaCl dissolved in 10 liters of solution. So what happens to the molarity? It goes up to 0.2 molar. Is that clear? So when you add more solute, you double the solute, maintain the same amount of solution, you increase the concentration of the molarity. Okay? How would I then weaken this? I can't just pull the salt out. You could separate the solution by boiling away the water. But if you boil away the water, if you boil some water away, right, what are you doing to the solution? You're strengthening it. Because if you boil this liquid away, this value might drop down to 5 liters. Okay, if you're down to 5 liters, then look at the difference now. It becomes 0.4 molar. So by boiling away some water, you can also strengthen the solution, but you're losing water, molarity goes up. Okay? So again, to strengthen a solution, add more solute or boil the solvent. Boil it off. Keep the same amount. To weaken it, you add more. To dilute it, you add more solution. You add more solvent. You add more solvent. Alright? So a couple things to think about. Alright? So boil away the solvent, get rid of that liquid, so there's more solute being dissolved by the remainder, by the rest of the solvent, right? That's going to strengthen it. And also you want to, or also add more solute, okay? So there you go. All right, I'm tired. It's Friday. Oh boy. All right. Do the rest of the problems. There's extra on the website. Hey, you got your test coming up soon. There's one more video, pH calculations, and that is it. There you go. Have fun. Get to it. All right. Bye.